Previous sessions, we have seen the beta function in its integral form and in terms of gamma function. We have also seen that the beta function is symmetric, and we have seen these two, let's say, identities. Now, let's try to figure out how beta of 1 by 2 comma 1 by 2 is equal to pi. And here we are going to exploit the relation between beta and gamma functions. So beta of 1 by 2 comma 1 by 2 is equal to gamma of 1 by 2 times gamma of 1 by 2 divided by gamma of m plus n, that is half plus half. In the denominator, 1 by 2 plus 1 by 2 is 1. Gamma of 1 is 1. So this disappears. We are left with gamma of 1 by 2 times gamma of 1 by 2. Beta of 1 by 2 comma 1 by 2 is equal to gamma of 1 by 2 square. Since we know gamma of 1 by 2 is root pi, we can say beta of 1 by 2 comma 1 by 2 is equal to root pi square, which is equal to pi. So we have beta of 1 by 2 comma 1 by 2 is equal to pi. Now let's look at another way of proving this by using this identity. So beta of 1 by 2 comma 1 by 2 is equal to 2 times the integral 0 to pi by 2 of sine to the power of 2 times 1 by 2 minus 1 theta times cos to the power of 2 times 1 by 2 minus 1 theta d theta. Simplifying that, we end up with 2 times the integral 0 to pi by 2 of sine to the power of 1 minus 1 theta times cos to the power of 1 minus 1 theta d theta. And this is sine 0 theta, cos 0 theta. Both are 1. So beta of 1 by 2 comma 1 by 2 is equal to 2 times the integral 0 to pi by 2 of d theta. Solving it, we get 2 times theta from 0 to pi by 2, which is equal to 2 times pi by 2 minus 0. So 2 cancel out and we are left with pi. Interesting, right? I is equal to the integral from 0 to infinity of e to the power of minus x square dx is equal to root pi by 2. This doesn't look anything like this. So let's see how we can prove this. Let's do the substitution. U is equal to x square. So du is equal to 2x dx. Now u is equal to x square means x equal to root u, which implies dx is equal to du by 2 root u. Now changing the limits, when x equal to 0, u is equal to 0. And when x equal to infinity, u is also infinity. So let's carry out the substitutions. We get I is equal to the integral from 0 to infinity of e to the power of minus u du by 2 root u, because that is what dx is. 1 by 2 can be taken out. So we have I is equal to 1 by 2 times the integral 0 to infinity of e to the power of minus u times u to the power of minus 1 by du, because here root u is in the denominator. So I is equal to 1 by 2 times the integral 0 to infinity of, what we are going to do is, we are going to write u to the power of minus 1 by 2 as 1 by 2 minus 1, which is the same as minus 1 by 2, times e to the power of minus u du. Now, do you recognize this integral? You have integral from 0 to infinity. That means it is not beta function. U to the power of n minus 1 times e to the power of minus u. So this is our gamma function. Gamma of what? Gamma of 1 by 2. So we have I is equal to 1 by 2 times gamma of 1 by 2. Gamma of 1 by 2, we know what it is. Root pi. So I is equal to root pi by 2, which is what we had to show. So we have seen another example. Now let's look at another. Here it says gamma of m times gamma of 1 minus m is equal to the integral from 0 to infinity of x to the power of m minus 1 by 1 plus x dx. So let's proceed. We know beta of m comma 1 minus m is equal to gamma of m times gamma of 1 minus m divided by gamma of m plus 1 minus m. So m disappears in the denominator. So we have gamma of m times gamma of 1 minus m. The denominator gamma of 1, which is 1. So now gamma of m times gamma of 1 minus m is equal to the integral 0 to infinity of y to the power of m minus 1 by 1 plus y to the power of m plus 1 minus m dy. This is one of the identities that we had seen. So gamma of m times gamma of 1 minus m is equal to the integral 0 to infinity of y to the power of m minus 1 by 1 plus y dy. And here, if you compare this integral and this integral, the only difference is the variable of integration. That is, here it is x, here it is y. So, and because the variable of integration doesn't matter what it is, in case of a definite integral, we can substitute y with x, which is what we had to show. That is another example. So that was beta and gamma functions. Now, if you found this helpful, don't forget to like, share, and subscribe. Questions, suggestions, comments are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.